AI is affecting all aspects of programming, development.
I think the average poet, the average writers, their careers over now.
Their careers
Their
are
careers are over now. The average writers, the average poets.
Besides ChatGPT, have been playing with certain tools that help me make videos out of just nothing but text. You feed it textual data, you describe what idea you wanted to create a video on, and boom, it creates the video.
Hello, friends. Welcome back to B Cubed, Season 2, Breaking Boundaries by Sabir Bhatia. This episode brings to you a very interesting and a different subject, which is evolution of hardware and software as prompted by AI. So very specialized. And for this, we have a very special guest, Chintan Tagi. Chintan has over 30 years of experience he has worked in very large corporates and consulting houses like Maruti, PwC, A.T. Kearney, and IBM Consulting. He has worked in geographies all over the world. His expertise is leveraging technology to design and build applications which are pertinent to small and medium businesses. He has successfully built a SaaS company which today has customers across 20 countries. He's an MBA from IIM Ahmedabad. Before that, he did his BTech from IIT Kanpur. Welcome, Chintan, to this show.
Thank you.
So, today's show is a very specialized show, and I don't know what I'm doing between the two of you here. You are the techies, and but nevertheless, I'll try and survive this next half an hour with you guys. So my first question to you is GPU, TPUs. What are they and how are they used in data centers to do with AI?
So before we talk about GPUs and TPUs, I think let's talk about the basic, which we use all today, which is CPUs. So the whole evolution is with CPUs, then GPUs, then TPUs, and moving forward, maybe a NPU. So CPU is what I would call as a most basic building block of a computer, which has been around for the last 40, 50 years. It works in a very sequential manner. It takes a command, works on it, and then takes on the next command. And as we all been playing video games and graphics for the last 30, 40 years, so GPU has evolved from a graphical card. So GPU is nothing but a graphical processing unit. It just works faster. It works in a parallel mechanisms. So it's the second generation of a CPU. Third generation would be a TPU, so a tensor processing flow. So basically, Google has invented this thing. So it is something which would be working at n dimensions, not just 2 dimensions, more dimensions than that. So the whole evolution is now the AI is depending a lot upon the GPUs and TPUs to take the work forward.
Yeah, and to continue with that, it turns out that the processing tasks required for AI-based computations, which is primarily something called matrix multiplication, is better suited to be performed by a GPU, and now, of course, an AI-specific processing unit, either a tensor processing unit from Google, or actually NVIDIA now has its own advanced GPUs. I don't know what they're called, but they are solely focused on performing AI-based tasks. So the big shift in the thinking over the last few years has been that the data center of the future will not be just processing data using CPUs, will not be a number cruncher only. It will actually be doing AI-specific tasks. And the thinking behind that is that all of software like we know it is going to have an AI angle on it. So software primarily used to be a sequential process-driven execution of a program or code. It was based on a certain algorithm.
Line by line.
Line by line, an algorithm. And that algorithmic way of thinking has undergone a change to accommodate a neural way of thinking, which is how our human brain actually works. The neural way of thinking is more of a decision-making system as opposed to a computational system. So because all of software is undergoing this AIification, if I may use that word, people are envisioning that data centers of the future will majority of their time be performing AI specific tasks. So to perform AI specific tasks, you have to have AI specific hardware, and that is the modern GPU or a tensor processing unit, and that is what will be used in in data centers of the world.
Okay, so neuromorphic computing comes from here.
Neuromorphic computing is actually the fourth generation. So if we count the generations, it will be the fourth generation. And what Sabir just now said, that it's trying to mimic the human brain. And behind neuromorphic computing would be the NPU. So it's just looking at things, predicting the way the data is going to be required. So the biggest problem with computation is the two dimensions to computation. One is storage and the other is processing. Now, traditional CPUs will look at information, read the information from the storage, and then process it. It takes time to do that. It takes power to do that. And when it consumes power, it heats up. So, power consumption, temperature monitoring, all those things are the problems which the CPUs and the GPUs are struggling with. The NPUs would be bypassing this problem by using different architecture. And here the architecture would be trying to mimic what the human brain does. So, we have neurons and we have synapses. So neurons are cells which do that specialized job within a brain, and synapses are the connections between those two cells. So we have, I guess, about 80 billion neurons and something like 3 trillion synapses. So the whole neuromorphic computing game is to trying to create a computer which is going to work like a human brain.
Mimic a brain.
Mimic a brain, not just like from decision making, but also from the way. See, our brain consumes something like, I don't know, 30 watts of electricity, 30 watts of power, which is very, very low. So we are super efficient and we are not heating up. We are not heating up. But look at a computer, they all heat up very fast. And they're not as strong as, not as powerful as a human brain. So the whole game is that how do we learn from a brain? How do we change the CPUs, bring it to the level of NPU, and make it work in a much less power consuming mode and much faster. And it's not about just being parallel processing. It is beyond parallel processing, because it's looking at predicting what type of data you will need for the next job. So you're looking ahead, and that's getting into domain of beyond just deterministic programming to more fuzziness into the programming space.
So I mean, then what is quantum computing?
I think so. We will take that.
Quantum computing. We need you to address this to our viewers because they need to understand this.
So yeah, quantum computing is a branch of computing where you have multiple states that an output can be, not just a 0 or a 1. It can be either a 0 or a 1. So it is indeterministic, but it uses something called qubits. And there are multiple dimensions of qubits. So if you have n dimensions, you have 2 to the n possible outcomes. Now, to distill it down for the ordinary, people to understand this, our traditional systems of cybersecurity and other things have certain number of bits of encryption, 256, 512. This basically, if you do the computation in n dimensions, you can theoretically break any encryption in minutes, because it can compute in parallel that much faster.
That's why quantum.
That is what is quantum computing. Now, of course, I've just given you a very superficial, broad, layman's term. There is, of course, a lot of intricacies and nuances. It's still in its developmental stage, but there is something called quantum entanglement. That is a phenomenon that subatomic particles also have, which is if one particle behaves in a particular way, the other particle responds
in one geography,
millions
of kilometers apart.
So this is a physics phenomenon. Of course, we are very far away from creating a computer where, imagine a computer which is built on these particles. They're called quantum entangled particles. You don't need any connection in between them. So if one behaves a certain way, the other will automatically respond.
I see.
In it's called something called a spin. So if one spins a certain way, the other will spin the same way. And I mean, we are very far away from achieving this, but when we do achieve this, all of the internet will be redundant, because you can build computers that basically talk to each other without any computing,
So
any connectivity.
I like to add to this. So while like Sabir said that quantum computing is built upon quantum physics phenomena, it's very difficult for human beings to understand what quantum physics is. We all think in terms of binaries, and that's how computing has evolved. So the basic underlying thing is a transistor and gates work on 0-1 principles. Either they're open or they're closed, and that's how computers today work. That's how everything today works. The underlying inside gate is a 0-1 gate. Now think of a gate which is not just 0-1, but all the possibilities in between. So it just increases the possibilities which the system can handle. So you're not giving a 0 answer, you're not giving a 1 answer, you're giving myriad answers, multiple answers. Now it's very difficult to talk about, but that's how quantum computing, that's what quantum computing promises. It's still very, very new. So I would say it's still less than 10 years in terms of real usage. And like what Sabir said, the quantum entanglement experiments are going on. Scientists are able to demonstrate quantum entanglement, and hopefully that's something which is going to add to the way the quantum computing is also going to evolve.
How very interesting. Uh, and I'll keep throwing these terms at you because I'm unaware myself. What is edge computing?
So edge computing is in AI. The first wave of AI required massive data center based computing, because all of the computation occurred in the cloud. You fed it massive amounts of data, and you asked it to recognize patterns that identified objects like a cat or a stop sign or a car or a human being crossing the road. But if you really think of how actual systems work, cloud-based computing is irrelevant. Today, if a car is driving and it has to make a decision whether to apply the brakes or make a right turn to avoid a passenger hitting a passenger, it has to make that decision locally. That is called edge computing. And edge computing has taken particular importance in the realm of AI, because if you wanted to make intelligent decisions on the edge, it has to operate on limited sets of data. You can't train it on massive amounts of data. An example is an edge computer gets only limited information from the lidars that it has or sensors that it has, and based on that, it has to make a very intelligent computation whether to stop the car or continue. As an example. So that is edge computing, really.
So it is deployed for autonomous.
That's one scenario, and maybe just to build upon that. So our mobile phones, those are the edge device. So that's the edge device which we carry in our pocket all the time. Now we all know the battery life, 12 hours, 24 hours, that's the scope of our battery which you have. So the challenge with edge computing is to again reduce the power consumption, provide autonomous local computational power on something which is at the periphery of the whole thing. So whether it's a mobile device, whether it's your car, whether there's a traffic light which is actually operating the signals. So maybe a real life example would be that today when we are driving back home and in the evening rush hour, sometimes we feel that, okay, this particular red light could be more working better by reducing the time, which is giving it 60 seconds red here and 90 seconds red there. So with edge computing, you'll be able to have an automatic correction of the way the red lights will work, because those are the places where the decision is being done. So you don't need to have a server sitting at one center and then giving instruction down to the devices. The devices will work automatically. And it also is required, I guess, now with more and more emphasis on data security and the data becoming, ownership of data becoming with the person who's actually creating the data. So with edge computing, your data might reside with you. There's a more possibility, and you will have more control on the way the data is going to behave. And if you don't want to use it anymore, you can just delete it. So that also is the promise of edge computing coming in future. So instead of your data lying in a server of Meta or Google, it's going to be lying with you on your device.
And what do you have to say about AI optimized architecture?
So yeah, this is just the back-end data centers once again optimized to perform AI-specific tasks. That is AI optimized architecture. And another way in the edge computing realm for that is when you've got sensors, let's say sensors that detect opening and closing of a door or something, and you want to, you want it to operate on some other data, like let's say an intrusion detection. So rather than sending that data to the cloud and the cloud telling it to shut the door or lock the door or trap the intruder, you make that decision locally. So that is emerging as a mechanism for performing decisions on the edge itself.
So basically, I think the whole movement is gathering momentum and trying to see where will the future come from. So when you look at a data center today, and the data centers have evolved in the last 20, 30 years, where what we see them as today, I remember maybe early 90s was when the data centers were really coming up with the reduction in the cost of bandwidth and the reduction in the cost of the computing power. The data center become bigger and bigger. And why Amazon and Google have grown so significantly is also because they have a very good competence in managing data centers. Now, their competency is managing large data centers for large server farms. What AI needs is different. AI needs computational power, which is today very, very expensive. If you run a project, if you run an AI project on using any infrastructure available today on the cloud, it is significantly expensive. It is not something which a average company or average enterprise would be able to afford. So the requirement is to change the way the data center is designed. So ultimately, the cost of running an AI-based application has to come down significantly. And that's where the movement is going on in terms of the AI-enabled data centers.
Which brings me to cloud and hybrid AI services. What exactly is the connotation of this?
So cloud traditionally has been when you take, where this is from 20 years ago, client server architecture into the cloud.
That's what you did.
That's what
That's how you
first
got hardware.
application. But now, certain companies will still require computation in the cloud. Companies that are in the fintech space and other space. Yet AI is increasingly taking up a lot of significant portions of their operations. So for AI specific tasks, you will have AI specific hardware, because the old hardware which was used to do computation is not ideal, for performing AI specific tasks. Like one of the examples, the most basic, action in an or task in an AI specific model is matrix multiplication. So you need to have hardware that's specializes in AI specific tasks, and a company that like NVIDIA has built libraries that enable AI specific tasks and operations to be performed. And so you will have hybrid cloud AI data centers.
So Javed, just to add on this, see, basically, I think we
Please.
still have to grasp the level of evolution in terms of what we are trying to address here. I was again reading somewhere that the that amount of data which a typical AI problem needs to solve, the number of parameters which are going up is not going up linearly; it's going up exponentially. So we're talking about petabytes of data. So petabyte is basically something like 2 to the power 50. So it's something which today's architecture is just can't handle. So like Sabir is saying, you will have to have both of them will coexist. Traditional cloud computing obviously will remain, and specific AI based data centers which are designed to address these type of computational requirements are coming up, will come up, and more work will start working on those things. So a hybrid model is going to be that both of them exist. The sexy word, the jazzy thing works happens on the AI based data centers. The traditional bread and butter work happens on the cloud data center.
So, any other tools for, I mean, AI specific tools that you might like to talk about for the benefit of our viewers?
Listen, AI is affecting all aspects of programming, development. I myself have been, besides ChatGPT, have been playing with, certain tools. that help me make videos out of just nothing but text. You feed it textual data, you describe what idea you wanted to create a video on, and boom, it creates the video.
So those tools are more in terms of generative AI tools. You're talking
That's
about,
right,
yeah, creating images, creating videos, creating
videos.
content.
And
Yeah,
they're getting more realistic. That's
absolutely.
the thing. It's
Yeah.
like, I mean, if you just let your imagination run wild, we are not too far off where you can just describe a movie in your own words and it'll make the movie for you.
Sci-fi.
We've all seen the poems which come out of generative AI engines. They are, I think the average poet, the average writers, their careers over now.
Their careers
Their
are
careers are over now. The average writers, the average poets. Yeah, you have to be much, much better than average. The top 20 percentile will survive. The basic work is being done by generative AI.
But just so many tasks are being automated. Accounting, you know, uh, uh, even in the legal field,
Paralegal, the
paralegal field,
paralegal works.
in also in medicine.
Banking, insurance.
In medicine, like folks that spent years studying how to read X-rays, how to read outputs of machines, and determine the kind of disease. AI is getting so accurate and so good at that now. So that's the that's on the job side, but on the application side, now imagine if we could use AI to deliver medicine or medical services to large sections of countries like India or Africa, where people just don't have access to medical services. So even though we know that it's not doctor, but at least they have a pretty good, AI engine that is, telling them the right thing, greater than 90% accuracy, that diagnosing diseases or advising them
So
medically.
one of the challenges which quantum computing actually is facing is exactly what Sabi is talking about, the level of accuracy which you get out of quantum computing algorithms. So they're still trying to address how to remove the noise out of the signals which they're getting. And they sometimes have inaccurate results coming out. So while we are trying to create larger and larger problem sets for them to solve, we also have to get them a much more accurate real life data, which is more easily got attained from a deterministic scenarios. You do 1 plus 2 plus 3 plus 4. They give you accurate data, but they take longer time. If you try to give a problem a scenario where it can create multiple thousands and millions of scenarios, you might end up giving a wrong data. So the balancing act has to be enabled now. So the AI game is now to how to balance out the accuracy of data, accuracy of the outcomes, and also to get the larger problems to be solved.
And all the while, people thought that the jobs that are going to go are the mundane, non-creative jobs. And I'm hearing from you that even creative pursuits and jobs are going to be threatened by artificial intelligence.
Any job that requires human contact and human touch is safe. And so in a way, actually, if you really think about the medical profession, more than 80%, I would guess, is not knowledge-based medicine. It's actually empathy-based medicine. It's the empathy of the doctor. You going to a doctor, telling the doctor your problems, your pains, your aches, and the doctor advising you, because a human is advising you, already relieves half of your problems.
Absolutely.
And the biggest thing the doctors have today is when you go to see them, have you consulted Google before you came to see me? So they know the threat of AI looming on their careers.
Yeah, but it's not just the knowledge bit. Like, it's the empathy factor. Like, like we were discussing in earlier, the National Health Service in UK did an exhaustive study on homeopathy. And they're like, it's a placebo. All of it is a placebo. Yet you ask, thousands of people, millions of people in India, they'll swear by it. But because of the empathy of somebody giving you this and telling your brain, the brain is a very powerful tool over here. It needs empathy. We need human empathy from each other. And if somebody tells us, just take this, you'll be okay, more than 80% is I give you a sugar pill and you'll feel great because I've told you so.
So that might sustain humanity, empathy.
Yes.
No, but Chintan, you spoke about writers, and you said there is only the 20% outstanding ones.
Percentile
How about
versions.
poets?
Absolutely.
Poets too?
So no, so you look at it like this.
Because-
have you tried getting a poem out of any generative AI tool? Just try it out yourself. Just try it out yourself, and you'll see the quality of the work they give you.
I see.
So they're going to be they're more better than the average.
Okay.
They're better than the average. Obviously, the acting part will not go away. You will not have AI actors unless you're doing completely animated movie with AI characters. That might happen in the future.
They won't display emotion.
They won't display actors.
No, they actually display emotion too. I mean, one of the 5 voices was Scarlett Johansson.
Oh yes.
Used by ChatGPT 4.0, and very realistic voice too. When the AI is teaching, ChatGPT 4.0 is teaching a kid how to solve a problem, mathematical problem, of a cosine or a sine, and it's as if it's a human talking to
Okay.
you.
It makes a difference. And what is software 2.0? For the sake of our viewers, there's so many things that are not clear.
See, again, this is a term which is coming up recently, but I would say it's also linked to the way the whole blockchain, cryptography, Web 3.0, they're evolving. So it's again providing not the traditional way of programming software, which is a linear method based, but this is depending on more and more user libraries. Libraries which are being created by companies like Google, Amazon, IBM, Metas of the world. So this is the different way of programming, so that you're baking in AI from the way you're trying to design the architecture of the software. You're starting at something, planning how AI will be used into the software overall.
So Chintan, having been for this lofty ride now, back to ground O,
Terra firma.
terra firma, need to ask you a very simple thing. AI. What will AI do for the common man, especially in India?
Let's think about what are the problems of common man in India. Health, education,
Jobs.
jobs. What does a farmer need? Predictability, some guarantee on that his output is going to be picked up from his farm or from the market. So I guess those are the problems which AI can help you solve, because it can work with lot of data. And luckily for us, some of these domains data has been created over the past so many years. So if you look at agriculture as a sector, you would have last 40-50 years of data of prices, demand, consumption, weather patterns. So as a farmer, if I am able to find out, predict for myself, I've got a 20-acre farm, what should I grow, and so that the probability of takeoff is the maximum for me. That's the problem I can solve.
I see. Okay, that's wonderful. So this was a very, very interesting discussion, I must say, and a lot to learn for me, and I'm sure a
All of us.
lot of our friends across. So thank you very much, viewers. If should you wish to ask questions, which I'm sure there'll be plenty of questions coming for this session, put them on our BCubed Showreel app, which you can download from App Store or Play Store. Put the questions there and send them to us. I'm sure Chintan and Sabir will be very happy to answer your queries. Thank you for watching. Thank you, gentlemen.
Thank you.